Okay, guys, today we're going to talk about our second kind of transformations, reflections. And yeah, it's kind of like what you are thinking about when you think of reflections. Look it in the mirror, right? You look in the mirror and you see a reflection. All right, um, so notice, so here's a reflection right here. Triangle BUG bug, triangle bug is being reflected about this line, and the vertices of triangle B prime, U prime, G prime. What I want you to notice here is that when we do a reflection, they read counterclockwise. Okay, notice that when you reflect a figure, the shapes have opposite orientations. And if you think about it, if you've ever read lettering in a mirror, it reads backwards, right? Okay, so what are we really trying to get you to think about right here? See that? So triangle BUG is the reflection triangle, and we write the reflection B prime, U prime, G prime, but it goes the opposite direction. And if you notice, they're not oriented the same. If they were oriented the same, this point here would be over here, and this side over here would be over here. That would be a translation from what we learned yesterday. When you reflect a figure across a line, each point of the figure maps to another point the same distance from the line on the other side. The orientation of the figure reverses. This is hugely important. Huge, really huge. When you reflect across a line, each point of the figure maps to another point the same distance from the line, but on the other side. Maps the same distance, but on the other side. Now, I'm going to take some time to explain that, but just check this out. See U prime here and U? If I drew a line that connected both points, what you would find is that this will be perpendicular, and this distance here, the distance from U prime to the reflection line, is the same as the distance from the reflection line to the U. So think about this. When you're looking in the mirror the next time, if you're putting on makeup or brushing your teeth or whatever it is you're doing in the mirror, think about the fact that when you're looking at yourself in the mirror, it's completely reversed. The image is reversed, number one. And number two, somewhere between you and the mirror is a middle point that is a line of reflection. Okay? That's the key point. A reflection across a line M, called the line of reflection, is a transformation with the following properties. Two properties, okay? Two properties. If point A is on line M, then the image of A is itself. That is, A prime is equal to A. If, and it's possible because if you get your nose and touch the mirror, your nose is now on the mirror. So the tip of your nose is on the reflection line, okay? The mirror, in that case, in all cases that we've been talking about with mirrors, the mirror is the line of reflection, okay? If point B is not on line M, point B is not, then M, this is M right here, the reflection line is M. M is the perpendicular bisector, huge word that you got to remember. I've been trying to teach a lot of you all year, and hopefully you're getting there. But it's the perpendicular bisector, which means this length is equal to this length. Okay? Okay? So from B to the line of reflection, and then, I need another color, orange. There we go. And from the point of line of reflection to B prime, this orange line and that green line are the same length. Really important, okay? So what are we doing in homework for homework 2 this week? And I think you'll find these homeworks this week are not that difficult. You should get through them pretty easy. Hopefully, well, those of you watching this video, you're doing your homework. Believe it or not, 1 out of every 3 people did not take my test online last week and they got zeros. That's just a shame. Breaks my heart. But got to take care of business. Okay. Point P has coordinates 3, 4. So I'm going to count 1, 2, 3, 1, 2, 3, 4. Hey, remember, in case you have forgotten, we always start at the origin with a coordinate and we go in the direction it tells us. Positive, positive. This is positive. This is the positive direction. This is the positive direction. This is a negative direction. And down here is a negative direction. So anything in the first quadrant is going to be positive, positive. Any coordinate in the second quadrant, and that's what the quadrants are, 1, 2, 3, 4, is going to be negative, positive. Anything in the third quadrant is going to be negative, negative. Anything in the fourth quadrant is going to be positive, negative. Okay, so this is point P, and it happens to be 3, 4. Okay, what are the coordinates of P prime if point P is reflected across y equal 1? Well, first thing I want to do is I want to find what it means y equal 1. Do you remember how to draw this line from Algebra 1? I hope you do. What it means is y is always 1. So if x is 1, y is 1. Okay? If x is 1, then y is 1. If x is 2, then y is 1. If x is 3, then y is 1. If x is 0, y is 1. If x is negative 3, hey, guess what? It's a horizontal line. Okay? I'm going to draw my line of reflection as a dashed line. Okay? And I'm going to label it y equal 1. That's what that is. So if we go back to our two key concepts, key points, if a point A, or in this case P, if point P is on line M, it's not on the line of reflection, line M being the line of reflection. It's not on it, it's off. Okay, so it's second bullet. If point B is not on the line M, then M is the perpendicular bisector of the line that connects P and P prime. So all I have to do is count 1, 2, 3, 1, 2, 3, and that's P prime. And that happens to be 3, negative 3. Okay, yeah. And so what I want to do is from here, 1, 2, 3, okay, and 1, 2, 3. All right, we're good. Because this line right here, if I draw it in, we can just count 1, 2, 3. So that is equal to 1, 2, 3 is equal to that. Okay, and this is a vertical and a horizontal line, so we know they're perpendicular. So 3, negative 3, P prime is 3, negative 3. Okay, be sure and trust your eyes if you're doing Math Excel. Use a graph, use graph paper, and do it. So now you try. So I want you to stop. I want you to turn the video, stop, turn it off in a moment. But I want you to plot point P. I want you to draw the line x equal 1. And then I want you to reflect point P across x equal 1. Once you're done, turn the video back on and check your answer. I hope you're back. So if you did this proper, you plotted 3, 4. And then you drew this line in here. This is x equal 1. X equal 1 is a vertical line. And if you stop and think about it, x is 1, y is 0. X is 1, y is 1. X is 1, y is 2. X is 1, y is negative 3. It's all those points. So all we're going to do here is we're just going to say P, and we're going to reflect it. And it's going in, well, I didn't write it, but it was 3, 4. And when I reflect it, it becomes P prime, negative 1, 4. Right there. Okay, that's side 1. Let's flip it over and go to side 2. Okay. Example 2. Graph points negative 3, 4, 0, 1, and 4, 2. All right, so I'm going to go graph those. I'm going to put some more paper under here so I have nice backing. Okay, so -3, 4. 1, 2, 3, 1, 2, 3, 4 right here. 0, 1 right here. And 4, 2. 1, 2, 3, 4, 1, 2. So this is A, this is B, and this is C. Okay, so I'm going to take a minute and I'm going to take my straight edge because I like to keep things clean. And I'm just going to draw these lines in real quick. We have a triangle. Okay, ABC. Now, graph and label the transform figure if ABC is reflected across the y-axis. Right here's the y-axis. Okay, so it's not hard, guys. Here's all you do. If I'm reflecting across a line, then and this is a vertical line, I'm just going to draw it across. But what I'm going to do to figure it out is I'm going to go like this. 1, 2, 3. 1, 2, 3. Okay, that's going to be A prime. B doesn't move because B is on my line of reflection, so that's B prime. C, I'm going to count 1, 2, 3, 4. 1, 2, 3, 4. You just count to your line of reflection and then count the same units away. C prime. Now I'm going to take my ruler again and I'm going to draw it in red. Okay, so my transformed triangle is the same shape, just reflected across the line y-axis, or x equals 0, actually. They're both the same line. So all we did was we did triangle ABC, and we reflected it. Reflected it across y-axis to get triangle A prime, B prime, C prime. By the way, these 3 points, I could write my other 3 points. It's going to be 3, 4, where this one was -3, 4. This one is 3, 4. B is the same. It's 0, 1. B prime. And C prime, this one was 4, 2. It becomes -4, 2. Okay, think about this. If you look at the values, 3, 4, and 3, and 4, one's positive, one's negative. 0, 1, 0, 1, that tells me that B and B prime are on the line of reflection. 4, 2, and -4, 2 tells me that they flipped over the y-axis because the x has changed. Okay, now I want you to stop the video. I want you to do exactly what I did. I want you to plot ABC, label it ABC, and then I want you to reflect it across the x-axis, and we'll see what it looks like. When you're done, turn the video back on, and I will have your solution. You should have had ABC just like I had up here. I went back with my highlighter and I highlighted my line of reflection. Okay, something that's really important that you should be thinking about is the fact that these vertices will all be, those two go together, these two go together, and these two don't move. They stay there. And that this line of reflection is perpendicular to your line that connects the two vertices and is perpendicular. So similarly, we have this one. Now, I didn't rewrite A, B, and C because they're up here. But something really kind of cool to notice is we reflected across the y-axis in example 2. And if you look, here was x and here was x. They changed signs. B doesn't because it's on the line of reflection. But if we look at C, the x values changed. Now, if you did this and you got this picture, you did it right. Good for you. Now, what we're talking about are these lines will be perpendicular and to the line of reflection. Okay, and they're congruent. You can connect all 3 of them if you like, but you're looking for that if you're looking to see if it's been a reflection. That's what you're looking for. Okay, number 1. Number two, this time, It was -3 and -3. They're the same, but it's 4 and -4. Check it out. We reflected across the x-axis, and the y value changed. We reflected across the x-axis, and the y value changed. The y value changed. Pretty important. Mathematics has a lot of patterns in it, and there's some patterns for you to recognize. So that's reflecting across a line of reflection. If we said y equal x, it would be the line here, and you would have reflected it across that. That takes a little more work, though, and we'll get there, and we'll talk about it. So, example 3. In each triangle in the diagram is a reflection of another across one of the given lines. How can you describe triangle 2 by using a reflection rule? So, which one goes with triangle 2? That's the big question. We're looking to see, well, 2 and 3 are not reflections because, for one thing, they're oriented the same way. So you know it's not 2 and 3. Okay? Could it be 2 and 1? The points are in the same direction again. I like that these two are across from each other. I'm going to turn my paper a little bit. Now I'm going to take my ruler and I'm going to connect vertices. Okay? I'm going to draw that line in. And I'm going to connect the right vertices. So this goes here and then up, and this goes here and then up. So these two go together. These two go together, which means these two go together. So I'm just going to line up my vertices, and I'm going to draw my line in. Now, check it out. If I'm trying to figure out, do I have a reflection across line K? I could always measure. I can put it on there and go, okay, that is about 1.2, maybe 1.3. And then I can double check it. But you know what? I'm just going to tell you, it looks like it is to me. Looks like these are all three perpendicular. Okay, this guy is congruent to that guy. This guy is congruent to that guy. And this guy is congruent to that guy. So what I'm going to say is triangle 2 reflects across line K, okay, to become triangle 4. Okay, so 2 and 4 are reflected. Now, what I would like you to do is try to figure out which one goes with 1. Okay, so check out 1 and see if you can't figure out which one it is, and then we'll come up with a rule. Do it, and then come on back to see the answer. Did you have these lines on your paper? Number 1. Did you draw in your lines and show that these two are equal at least? These two kind of run into each other, but they're perpendicular. And you said triangle 1 reflects about line M with triangle 3. That would have been your rule from that picture. All right, guys, this video was a little bit longer than the other video. We had a little more to talk about. Your homework this week are Math Excels, one on translations and one on reflections. See you Wednesday.